In Chapter 2.1, we're going to discuss systems of linear equations. A linear equation, something like 2x plus 3y equals 10, will represent a graphed line. And every single point on this line, the xy values, will be a solution to this equation. And every solution to this equation will be a point on this line. Now we're going to discuss a system of linear equations. A system is made up of two or more of these equations. We're only going to be discussing two of these equations at a time. So let's take a second equation. Negative 5x plus 7y equals negative 11. And we're going to say the same thing about this. That equation will represent a graphed line, and every point on this graphed line will be a solution to this equation. Now, since it's a system, meaning there are two of these equations, let's try to find one point only that is a solution to both of these. And if that's the case, and we can find that one point, then that means that it will satisfy and be on both of these lines at the same time. And the only place that happens and occurs is right here where the lines cross. And that is called the point of intersection. And so we say a solution that satisfies both of those equations, it will show two lines crossing or overlapping at that one point of intersection. And in section 2.1, we're going to determine the solutions of the system of linear equations. I'm going to be going over the question quickly, just so you can understand the concept of what we're doing. After this, you should go and watch the other videos that have example problems in them. Question: is the ordered pair, this point, negative 2, negative 4, a solution to the given system of equations? In order to be a solution to the system, that point must be a solution to both of the equations. So we're going to go ahead and write down both equations and solve each one separately and see if that point would be a solution to each one. So we go ahead and take the point and we substitute the xy values in, and we're going to come down now with a true statement. Since it's a true statement, yes, that point, negative 2, negative 4, is a solution to this one equation. Now let's go over to the other equation and see if it's a solution there. We substitute the xy values and we come down with another true statement. So therefore, yes, that point is also a true statement for the second equation. Therefore, that point is a solution to both equations. It then is a solution of the given system of equations. In general terms, if we have a point and we're given the two equations that make up the system, if we go ahead and take that point and substitute it into both of these equations separately, and we come down and we find that it may be a solution to one of the equations and not the other equation, then therefore it is not a solution of this system of equations. Now here we see it wasn't a solution to example 2. Well, maybe it wasn't a solution to example 1. That would still mean that it does not satisfy both of the equations and would not be a solution of this system. This is the end of this video.